Hi everyone, welcome to Vin's workshop. Today we talk about an introduction of functions. So first of all, let's talk about domain, range, and function. We have a definition here. It's not a definition. It's the way I understand the problem. Domain is the set of all possible x value, and range is the all possible y values. And a function is the set of ordered pair in which to each member of the domain corresponds exactly one member of range, which means they try to tell you that one domain just have only one range, exactly one range. So what does that mean? So I make one example here to demonstrate what about the definition of the function. So in example one, we have the setup like Mike want to go to Hawaii, Amanda want to go to New York, and Kyle want to go to LA, and Miguel want to go to Jamaica. So we say that domain is the set of all x value. If we look at this one as a point, then you will have x value here and y value here, x, y, x, y, x, y. Okay, so let's list them all down. My domain for this one is domain for this we have Mike, we have Amanda, we have Kyle, and Miguel. So they are the domain because they stand at x position place. And how about range? So range is the y value. So in this case, all the places is my range. So I have Hawaii, I have New York, I have LA, and I have Jamaica. Okay. Now let's say domain is stand for people. Okay. And let's say range is stand for places. So we have range stand for places. Okay. So let's make two diagrams here for, let me see, that's not big enough. Let's go where. All right, let's say domain, I fill in the information we have. We have Mike. Domain, we have Mike, we have Amanda, we have Kyle, we have Miguel. Okay. And places, we have Hawaii, we have New York, we have LA, and we have Jamaica. Okay. So as we see on the graph, Mike want to go to Hawaii, and as you see on example one, we see that Mike want to go to Hawaii, Amanda want to go to New York, Kyle go to LA, and Miguel go to Jamaica. So as you see in this one, if I say all of them go to that places at the same time, like Mike go to Hawaii, Amanda go to New York, Kyle go to LA, Miguel go to Jamaica at the same time, so it still makes sense. It still makes sense. So yes, it's a function. Is a function. But let's say because follow the definition, you see that one domain corresponding exactly one member of range. As long as you have one domain, one range, we will be fine. So let's say if I let I revise this one and change a little bit. Let's say Miguel go to Hawaii and Amanda go to Hawaii. Kyle go to LA, Miguel go to Jamaica. So let's say now they go to Mike and Amanda go to Hawaii at the same time. So it's okay for two people stay at the same place at the same time. So it still makes sense. And also based on this one, one domain has corresponding one range. So two domain has the same range, it still be okay, so it still makes sense. So this one is still a function. It's a function. Function. Okay, so how about if I change this like this? Let's say Mike go to Hawaii and Mike go to New York. Amanda go to New York, and Kyle go to LA, and Miguel go to Jamaica. So let's say if they all go at the same time, so we have the conflicts problem here. Mike go to Hawaii and Mike also go to New York at the same time, which does not make sense. Mike cannot stay at two places at the same time, so now it's not a function. Not a function. Okay, so one domain cannot have more than one range. This domain had two range, and he cannot stay at two places at the same time. Okay, that's why it's not a function. Now let's go over example 1. We have the set of points, which is -3, -8, 0, 0, 2, -3, 4, -8. So first step, we have to find out the domain and range. So first step, we find the domain and range. So domain of this one is, as you know, domain is the x value. So I pull out all the x value. So we have -3, we have 0, we have 2, and 4. That is my domain. And now how about range? What is my range? Range is the y value. So we have -8, we have 0, we have -3, and we have -8 again. Since -8 repeat twice, you don't have to rewrite it. That's it, just that. Okay, now let's graph this one. So domain, and don't forget domain stands for people, and we have range. Range stands for places. So let's write down here places. And we have people here. Let's write down here amount space people. Okay, so I fill in the number. So -3, 0, 2, 4, and range is -8, 0, -3. Now make the arrow. So we have -3 go to -8. So -3 go to -8. 0 go to 0. We have 2 go to 3. And we have 4 go to -8. So 4 go to -8. So as you see that we have -3 go to -8, 4 go to -8 at the same time. So it still makes sense for two people stay at the same place. So the answer for this one is yes, it's a function. Yes, this says is a function, or is a function. Okay, yes, it is a function. Okay. So make sure when you do those problems, list down domain and range, and graph them all out. Which one repeat twice, you don't have to rewrite it. Okay, the next one is the cell check. I want you to try to work on it and see how far do you understand on this domain and range already. Cell check, I have 3 problems for you to practice on. Go ahead, work on them. Make sure you don't skip stuff. List down all the domain and range. Which one repeat twice, you don't have to rewrite it. And that's pretty much it. And see it makes sense. Can people stay at 2 places at the same time? So good luck everyone. Try on it, and then we will discuss about this one in the next few seconds. Alright. So I believe you have your answer already, so let's go over this one. So my domain on this one is again, my domain on this one is -2, 0, -4, 0 repeat, so I don't have to write 0, and then 1. Okay. And my range for this one is 8, 10, 6, 12, and 5. Domain and range. Okay, my domain is -2, 0, -4, and 1. My range is 8, 10, 6, 12, then 5. Okay, let's say where it would go. -2 go to 8, -2 go to 8, 0 go to 10, 0 go to 10, -4 go to 6, -4 go to 6, 1 go to 0 go to 12, so 0 go to 12, okay, and 1 go to 5. So on this problem, you see that 0 go to both places at the same time. 0 stay at 10 and also 12 at the same time. So this one is not a function. Not a function. Now we do the same for the last two. So domain on this case is my x value is 5, 10, 15, and my range is only one number. So range is 15, even they repeat 3 times, but you just write as 1. Okay. Now let's make a chart for that. Okay, here my range, and one more circle for the domain. Okay. That not a good one. Okay, here we go. So domain is, we have domain is 5, 10, 15, 5, 10, 15, and my range only one number is 15. So we have 5 go to 15, 10 go to 15, 15 go to 15. 3 of them stay at the same place at the same time. It still be okay. So this one, yes, is a function. It's possible. 3 number or 3 people stay at the same place is right. Okay, how about this one? Domain is -4, -1, 0, and -1 again, so that's it. And my range on this is, the range is 6, 0, -3, and 2. Now let's make the graph for each of them. Okay, the domain is -4, -1, and 0. Range is 6, 0, -3, then 2. Let's see where will it go. So -4 goes to 6, -4 goes to 6, -1 goes to 0, -1 goes to 0, 0 go to -3, 0 go to -3, -1 go to 2, -1 go to 2. Ha! Then -1 stay at 2 places at the same time. So this one another, not a function. Not a function. There you go. One person cannot stay at 2 places at the same time, but it's okay for the whole family or the group of friends stay at the same place at the same time. Alright, so I hope I give you some idea between what is function, what is not function, what is domain, what is range. Please make sure don't skip step. Alright. Now let's look on example 2. They're asking us graph y equal to 3x minus 2. Question A, find 3 solutions, identify the domain and range. And then problem B, graph the function, then tell the domain and range, probably based on the graph. So let's go ahead solve problem A. So in problem A, Problem A, we find 3 solutions. So I have to do is make x and y value table, and then choose a value for x, plug into the function, and get corresponding y value. Let's say if I choose x is 0, then we have y equal to 3 times 0 minus 2, which is 0 minus 2, give me negative 2. So the corresponding y value is negative 2, 0, negative 2 is my first point. Let's say if I choose x is 1, so y equal to 3 times 1 minus 2, so it will give me 3 minus 2, which is 1, so 1 and 1. Let's say if I choose x is 2, so y equal to 3 times 2 minus 2, give me 6 minus 2, which is 4. Okay, 2 and 4. So we have this point. I'm gonna put them in the graph. So we have 0, negative 2. 0, negative 2 is right here. Okay, 1 and 1, 1 and 1 right here. Okay, then 2 and 4, 2 go up 4 right here. Okay, then we have 3 points on the graph. So last time we talked about domain and range. So we have an idea that the domain is the x value. So my x value in this case is 0, 1, 2. Okay, and my range on this case is negative 2 and 1, then 4. Okay, to find out is this one a function or not, we did draw a circle. So I'm gonna draw two circle here, or 2 ellipse, either one, which one is work. So I draw 2 ellipse here. We have the point is domain is 0, 1, 2. Range is negative 2, 1, 4. Okay, 0 go to negative 2, 1 go to 1, and 2 go to 4. So it makes sense. 3 of them go to 3 different places at the same time. It's still okay. So this one, yes, is a function. Okay, now they're asking you graph. In problem B, they ask you graph it and tell the domain and range. So problem B, let's say this one is, we're solving B right now. B, find the domain and range. So as you see, we have 3 points on the x and y coordinate. So my next job is draw the line, go through all 3 dots. So we draw the line, go through 3 dots. We have the thing like this. Okay. Yes, it is. Okay. And also on this side, like this. Okay, so as we see that we did talk about this, the domain is the x value. So let's say this point, from this point I can bring it to the x axis. Let me change this. Okay, at the point right here, which point is 0, negative 2, I can bring this point to the x axis. It's not clear enough blue. Let's use the blue. I can bring every single point to the x axis. We have this one is 0, this one is 1, and this one is 2. 0, 1, 2. We have 0, 1, 2. 0, 1, 2 is matched with my graph before, and I can also bring it to the y value. Every point I can also bring it to the y value. So this point right on the y axis, so we don't move it. And this one we bring it to the y value, give you 1, and this one give me 4. So we have what? Negative 2, 1, 4. Negative 2, 1, 4. It's matched with the graph. Now with that idea, I can do is bring every single point on the line, any point on the line, to the x-axis. Then we will see things like this. Okay. Every point you can bring to the x-axis, and also on this side. Okay. And know that 2 ending right here is still extend forever. So we keep going down and down and down on both sides. That start from negative infinitive to positive infinitive, and they never stop. Okay, so my domain for this graph is negative infinitive to positive infinitive, because to ending is to extend further and further. They never stop. So we start from negative infinitive to positive infinitive. How about the range? So every single point can bring down to, let me change this one. Every single point can bring down to the y-axis. So as you see, if I bring it to the y-axis, we have things like this. Okay. As you see, and to ending, they extend forever. So my range on this case is from negative infinitive to positive infinitive, because they start from all the way down here to all the way up, whereas positive infinitive is. Okay, I hope that I give you some idea the domain and range based on the graph of the function. Now let's talk about 7 basic functions, or which can also be known as parent functions. So first of all, identity function has the equation like this: y equal to x, and the graph of this function look like this. It's a linear function. And squaring function is y equal to x squared, and the graph of this one look like a U shape, which can also call a parabola. So it's look like this. Parabola function. The third one, square root function, is y equals square root of x, and the graph of this one look like a curve like this. Cubing function is y equal to x cubed, and the graph look like this. It's really important to remember 7 basic parent function. Make sure you spend some time, let's say 5 or 10 minutes, to remember the function and how the shape of that function look like. It's really important. And q root function is y equal to q root of x, and the graph is the sideways, as like the one cubing function is sideways. You see thing like this. Reciprocal function, y equal to 1 over x. Reciprocal function, the graph look like a butterfly. Look like this. It's a butterfly. And absolute value function, y equal to absolute value of x, this look like a V shape. Look like this. Okay. So now let's talk about domain and range. So last time we learned that domain is the x value. So let's say the first function, every single point on this graph, I can bring it to the x-axis. So as you see, so the domain of this function is from negative infinitive to positive infinitive. How about the range? So every single point on this graph I can also bring down to the y-axis, and it's also cross the point 0, 0 and go over it. So it's also from negative infinitive to positive infinitive. How about the squaring function? Let's talk about domain. So domain, everything have to bring down to the x-axis. Okay. Here, 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 here. And don't forget to ending point is open wider and wider and extend forever, which means this one also start from negative infinitive to positive infinitive. How about the range of this one? So you see the point start at 0, 0 and they open up. So every single point when I bring to the y-axis, you will see we start from 0 and we're going up to positive infinitive. So it would be bracket 0 to positive infinitive. How about the domain of this one? So we start from 0 and every point bring to the x-axis. Okay. So domain is from 0 to positive infinitive. How about the range? And it's extend forever on that side. So the range start from 0 to positive infinitive. Now cubing function, the domain of this one, if you already have an idea what I'm doing, you can pause the video and try it on your own and see do you have the same answer like me. Negative infinitive, positive infinitive, and also bring to the y-axis. So we have the range is from also negative infinitive to positive infinitive. And this looks like the same on this. It's the same on this one. Okay. So domain is from negative infinitive to positive infinitive, and the range is also negative infinitive to positive infinitive. Now this is different. The domain of this one, let's make a graph here and start from this side. As you see, every single point you bring to the x-axis, they go through except the point 0, 0. Any other graph they cross through the point 0, 0, but not on this one. So the domain of this one is negative infinitive to 0 union parenthesis 0 to positive infinitive. The parenthesis which means not included. The 0 not included in the set of the domain. So how about the range? So let's do the range. Okay. So as we see that the range is the same thing, they go from negative infinitive and go to 0, union 0 to positive infinitive. The purple line doesn't go through the point 0, 0. That means we have to accept the point 0, 0. Now last function, we do the same thing. Bring it down to the x-axis in the point. So my domain is from negative infinitive to positive infinitive, and my range on this one is from 0, and you see we start at the point 0 to positive infinitive. Okay. I hope that I give you some idea about domain and range of 7 basic functions. The idea is bring every single point to the x-axis to get the domain, and bring every single point to the y-axis to get the range. Alright, so if we look at the 7 basic functions, The range is the one we cannot predict because we gonna shift the graph around, but the domain is the one we can see it before we actually graph the function. So look through all 7 basic functions. There are only 2 special functions we need to keep an eye on. Any other one, the domain stay exactly the same. Just only 2 have the different domain. So identity function, the domain is our real number. Square function, also our real number. The square root function, you start from 0 to positive infinity. So this is the different guy. This guy is special. Okay. Cubing function is also the same, our real number. Cube root function is the same. Reciprocal function has the domain except 0. So which means this one is another another important function, and this one domain stay the same. So let's talk about why those guys have the restriction. So first of all, I need to erase the one we don't need. No, I just move it up. So there's 2 special functions we need to keep an eye on. So if you have 1 over x, we know that the denominator cannot equal to 0, because if the denominator equal to 0, for example 1 over 0, that will give me undefined. Okay, so when you have a fraction, the bottom cannot equal to 0. I don't say that x not equal to 0, I say that the bottom, the denominator, cannot equal to 0. And the second thing, when you have the square root, we see that x have to be positive, because if you have the negative inside of square root, that is not real number, that is imaginary number. That's why when you have the square root function, whatever inside of the square root have to be greater than or equal to 0. Again, I didn't say that x have to be greater than or equal to 0. Whatever inside have to be greater than or equal to 0. Okay. So that is 2 important notes you should write down. Anytime when you hear about the domain, find the domain. There's 2 things you need to keep an eye on. Do we have fraction? Do we have radical? If we have fraction and radical, that follow with the restriction we need to remember. Any other function will be our real number. Okay, so let's go to the next example. You will see more clear what I'm talking about. All right. Example 3. Find the domain of each function. They give you 3 problems and they're asking you about the domain. Last time we did talk about this one. The domain has 2 restrictions. If you have a fraction, the denominator cannot equal to 0. If we have a radical, then the thing inside have to be greater than or equal to 0. Okay, so in problem A, we have f of x equal to 5x plus 3. So this one in the form of y equal to x, and the graph would be the graph is the straight line. Okay, so the domain of this one would be our real number, negative infinity to positive infinity, or it's also because the reason we don't have the fraction or square root. Okay, next one, h of x equal to absolute value of 2x plus 1. So this is the absolute value function. It looks like this, and the graph is the V shape. The graph of this one is the V shape. And the domain of this graph would be from negative infinity to positive infinity, because we don't have any fraction or radical. Now this problem C, this is the type, this is a fraction, so the type of the reciprocal function 1 over x, and the graph of this one will look like a butterfly. Okay. So we have the restriction in this domain. The domain of this one is the denominator cannot equal to 0, because if it equal to 0, that will give you undefined. So we do is set x minus 3x minus 6 not equal to 0. Then we solve for x. So plus 6 on both sides. We have 3x equal to positive 6, and we divide both sides by 3. then you have x equal to 2. X equal to 2. And my bad, we're talking about not equal to, so I'm going to cross this out. Which tell me that it will be all real number except 2. Okay. Negative infinity, positive infinity, mark a point, that is my 2. And we just say that it cannot equal 2, so I cross this out. So my domain is start from negative infinity to 2, parenthesis, union, from 2 to positive infinity. That is the domain of the fraction. Okay, let's repeat the concept. We set the bottom not equal to 0 and solve all the way through. When you get x equal to something, then you put the solution on the number line and cross that solution out because we say that it cannot equal to that solution. Then write your answer in interval notation. Now in the last problem, you have q of x equal to square root of 2x plus 12. So as we learned that if you have the radical, whatever inside have to be positive. So the domain of this one is 2x plus 12 greater than or equal to 0. And we solve for x. So subtract 12 on both sides, you will have 2x greater than or equal to negative 12. And we divide both sides by 2. That will give you x greater than or equal to negative 6. Now if we put this one in number line, negative infinity, positive infinity, mark a point that my negative 6, and I use my trick, put the inequality sign, that point may go to the left with the bracket. So, and if you use my concept, make sure the variables stay on the left side. So that point to the positive side, then my answer would be negative 6 to positive infinity. And that is the domain of problem D. So in this video, mainly we talk about the domain and range. I hope that I give you some idea about domain, range, and how to solve them in a function. So as always, thank you for watching.